Welcome to the video on conditional probabilities and independent events. So first we have what a conditional probability is, which we've talked about in a previous video. It's the probability of something given that another thing is true. So your probability of A given B is the probability of A intersect B over the probability of B. So in your Venn diagram, you have the probability of A, which is this entire circle, the probability of B, and the probability of A intersect B. So the probability of A given B would be if you know that B is true, so you know it's in this circle, you want to know what the probability of A is, so it would be this amount here divided by this here. And you can rewrite the equation like this. So an independent event is when you know the probability of one thing and it doesn't impact your knowledge about the other. So your probability of A given B is still the probability of A, and that's also equal to the probability of A given not B. So to test for independence, you'll find the probability of A, then the probability of A given B, and if they're equal, then the events are independent. So for example, are the events of getting a heads and rolling a 4 independent? So the probability of getting a heads is going to be these 6 outcomes out of the total 12. So it'll be 6 out of 12, which is 1/2. And then the probability of heads, given that it's a 4, would be, if you looked at your row, we're given that it's a 4. So there's 2 total outcomes, so it'll be out of 2, and one of them has heads, so it'll be 1/2. So this means that the events of getting a heads and rolling a 4 are independent because the probability is 1/2 still. So yes, they are independent. And that's because rolling a dice and flipping a coin, those are completely separate events. It doesn't matter what number you roll, your heads and tails still have the same probability. So here we have our first IB practice question. It says, several people were asked to select their favorite foods from a list. The results are shown in the table. A, what is the probability that a female likes tacos? So a female would be just this row, and we're looking for the probability that they like tacos. So it'll be 54 out of the total of that row. So out of 133. That can't be simplified, so this would be your answer for that. Part B says, what's the probability that a spaghetti lover is male? So we'll look at our spaghetti row, and then we want to know the probability that they are male. So it would be 14 out of the total, which is 14 plus 35, so 14 out of 49. You can divide both of those by 7 to get 2 over 7, so 2/7. And then C says, is loving pizza independent of gender? Explain. So our probability of loving pizza is going to be our total of our pizza row divided by our total of everything. So that would be 61 plus 44, which is 105, out of our total number, which is 250. So that can simplify to 21 out of 50. So that's our probability of pizza. So let's look at our probability of loving pizza given that the person is male. So that would be out of our total males, which is 61 plus 42 plus 14, so out of 117, 61 like pizza. And then our probability of loving pizza given that they're not male, which is the probability of loving pizza given that they're female, would be 44 out of the total females, which was 133. So if we write these as decimals, this first one is 0.42, and then we have approximately 0.52 and 0.33. So as you can see, the probability of loving pizza is not equal to the probability of loving pizza given that they're a male and it's also not equal to the probability of loving pizza given that they're not male. So this means that loving pizza is not independent of gender. And this is because the probability changes if we know the gender. Now we have our second IB practice question. It says, in a survey of 100 people, it was found that 74 people liked dogs, 50 people liked cats, and 50% of the people who liked cats also liked dogs. Part A says, what's the probability that a dog lover likes cats? So we have two different options here, so we can draw our Venn diagram where one side would be dogs and the other side would be cats. So it says 74 people liked dogs. So our total for dogs is 74, and 50 people liked cats. So that means the total for cats is 50. And then it says 50% of the people who liked cats also liked dogs. So 50 times 50%, or 0.5, is 25. So 25 of the people who liked cats also liked dogs. So that's going to be our middle section, which means the remainder for cats is 25. And for dogs, in the rest of the circle, it would be 74 minus 25, which is 49. So this part of the circle is 49. So part A says, what's the probability a dog lover likes cats? So this is the probability that someone likes cats given that they like dogs. So that's equal to the probability of cats and dogs over the probability of dogs, which is the probability of cats and dogs is this middle section, so 25, over the probability of dogs, which is the total for dogs, so 25 over 74. That's your answer to that one. Part B says, what's the probability that a person liked cats and dogs? So the probability of liking cats and dogs is this middle section, and then it's out of the total. So the total number of people was 100. So this would be 25 out of 100, which simplifies to 1/4. Finally, part C says, is liking cats independent of liking dogs? Explain. So first we'll find our probability of liking cats. So that's going to be the total number of cats out of the total, which is 1/2. So our probability of liking a cat, given that they're a dog lover, was found in part A, and that was 25 over 74, which is approximately 1/3. So because the probability of liking cats is not equal to the probability of liking cats given that they're a dog lover, then we know the events are not independent. So liking cats is not independent of liking dogs. Because the probability of liking cats changes if we know they like dogs. So that's it for that question. So in summary, conditional probability is the probability of something given that another thing is true. And we know an event is independent if knowing the probability of one thing does not impact our knowledge about the other. To test for independence, you'll find the probability of A, then the probability of A given B, and if they're equal, then the events are independent. That's all for this video. Thank you for watching.